Hello, I am Dr. Bob. I am going to show you how to install and set up the Yuasa Sliding Folding Test Jig FU. I will be using the motor drive unit DMLHP. We are starting with the two pieces separated as if you have just removed them from their shipping boxes. Place the motor unit on the left with the power cord connection on the left. Place the FU jig on the right with its back to the left and the sample clamps on the right. This is the way the units will face when they are joined together. There are only a few tools and parts you will be using. First is a T-type hexagon bar wrench. I call it an Allen wrench. It is a 3mm hex wrench. Second is an open-end wrench, 8mm on one end and 10mm on the other end. This is the linear output shaft, which is used when the DMLHP is used in the linear reciprocating mode. Only attach the linear output shaft when it is being used. It attaches through a hole in the motor unit. The FU is driven by the linear drive output of the motor unit, so we'll be using the linear output shaft in this video. Make sure you never ship the motor unit with the linear output shaft attached. You can damage the motor unit and the shaft. This is the motor unit AC power cord with a 3-prong to 2-prong adapter for use when needed. All those parts should be in the motor unit shipping box. The following items are parts for the FU jig. This is the joint bracket which holds the FU jig against the motor unit. I have already installed it on the motor unit. The screws to attach the joint bracket to the motor are already installed. These are the screws to attach the joint bracket to the FU jig. Some earlier versions of the FU jig do not use the joint bracket. These are floating joints which go on the end of the linear drive shaft and couple to the moving slider of the FU jig. I am showing two different types of floating joints. This one, round with a spring, is for the current version of the FU jig. This one, hexagonal and without a spring, is used for some earlier versions of the FU jig. And there is a safety cover for the entire FU jig. For your safety, the cover should be placed on the jig any time the jig is operating. This version of the safety cover does not have an interlock to stop the motor if the safety cover is missing. For this video, I will use the jig without the safety cover so you can see the operation of the jig better. All those items should be in the FU shipping box. The motor drive unit DMLHP can be used in the linear reciprocating mode or in the rotary reciprocating mode. Converting from one to the other is easy. For the linear reciprocating mode, you install the linear reciprocating shaft through the hole in the front of the motor unit, attaching it internally to the linear guide. And you install the rotary shaft cover over the rotary reciprocating shaft on the left side of the motor unit. I have already installed the rotary shaft cover. And you set the motor unit for linear drive using the touch panel. For the rotary reciprocating mode, you remove the linear reciprocating shaft and you remove the rotary shaft cover, and you set the motor unit for rotary drive using the touch panel. Please refer to the DMLHP motor drive unit setup and operation video for information on how to use the DMLHP. That will not be covered in this video. Note that some earlier versions of the FU do not use the joint bracket. Those FU jigs simply push up against the motor drive. Let me show you how to install the joint bracket. If you're using the joint bracket, in order to install it, place the motor drive on its side, not on its back. You could damage the connectors. The attachment point is on the bottom of the motor drive below the linear drive shaft opening. Attach the joint bracket to the motor drive using 2 screws. The 2 screws may already be in the motor. Tighten the screws with 3 Nm torque. Attach the appropriate floating joint to the linear drive shaft. I am showing both types of floating joint, but I will install the previous version floating joint. Tighten with 9 Newton meters torque. Then insert the linear drive shaft into the opening of the motor drive and attach it. Tighten the linear drive shaft, not the floating joint, with 9 Newton meters torque. Push the linear drive shaft into the DMLHP. With the DMLHP turned off, this will be easy. With the DMLHP turned on, you will not be able to move the shaft. The FU jig I have here is an earlier version. I want to show you how to install both the earlier versions and the current version. I have placed the FU jig on its side to show where the floating joint couples to the moving slider. This is the floating joint, and this is the hole in the moving slider the floating joint fits into. You will lift the jig and lower the moving slider connector onto the floating joint. I have removed the joint bracket from the motor because I am installing an earlier version of the FU that does not use the joint bracket. Lift the left end of the jig and insert the floating joint into the moving slider. You might need to move the drive shaft or the moving slider to do this. Then lower the left end of the FU to the bench top and simply push the FU against the motor with the rubber bumpers touching the motor. Use a long 4mm hex wrench through the back side of the moving slider to tighten the screw at the end of the floating joint to lock the moving slider to the floating joint. Be careful that you properly align the earlier versions so you keep the linear drive shaft and the floating joint in a straight line coming out of the motor to the FU's moving slider connection. The earlier versions of the FU are now completely installed. The current version of the FU has one step remaining. To illustrate the current version of the FU, which I do not have here, I will use an ST jig because the installation is the same as the current version of the FU. As before, you lift the left end of the jig and insert the floating joint into the moving slider. You might need to move the shaft or the moving slider to do this. Then lower the left end of the jig over the joint bracket. Two screws will be used to hold the jig to the joint bracket. They may already be in the jig. If so, you will need to remove them before you begin this step. Install the two screws through the joint bracket. Tighten them with 3 Nm torque. Now the current version is completely installed. Our next step will be to prepare the FU for a sample. There are 4 different setups depending on the size of the sample. I will illustrate all 4 of these cases with an animated slide. Thanks to Now Ando of Yuasa Systems for providing this slide and all the other illustration slides. Case 1 on the left is what I call the normal case. The sample is cut to use the maximum motion of the FU jig. Every portion of the sample, except for the portions under the clamps, will be folded and unfolded. The orange portion is folded and unfolded 2 times each cycle. The second case is when the sample is longer than in case 1, but it is mounted the same way. In this case, because the sample is longer than the maximum motion of the FU jig, portions of the sample after exiting the sample clamps will not be folded. Those portions appear as a bluish gray in the animated slide. The orange portion is folded and unfolded 2 times each cycle. The third case is when the sample is shorter than case 1, but it is mounted the same way. In this case, because the sample is shorter than the maximum motion of the FU jig, a portion of the sample may never be straight. It is shown in red in the animated slide. The fourth case is when the folding radius is large. In this case, the portion that is never straight, shown in red, can be much longer. The next slide shows the calculations used to set up the samples. There are 4 variable parameters: the length of the sample, the folding radius, the sliding distance or stroke of the jig, and any excess length of the sample. There are 2 lengths. One is the testing portion of the sample, the other is the total length of the sample. The difference is only the clamping portions of the sample. We will use alpha for the lengths of those portions. The clamps may be different, so we use alpha 1 for the lower clamp and alpha 2 for the upper clamp. These lengths can vary among the different versions of the FU jig. The version I am using has alpha 1 equals 9 millimeters and alpha 2 equals 22 millimeters. The folding radius is the second parameter. The folding radius range can vary among the different versions of the FU jig. The version I am using has a range R equals 4 millimeters to R equals 80 millimeters. The third parameter is the sliding distance or stroke. This is set on the motor drive unit. With the HP I am using, it is set using the touch panel. With the HP motor drive unit, it is a mechanical setting that is accessed through a removable port cover. With all the motors, the maximum stroke is 120 millimeters. The fourth parameter is the excess length of the sample. The excess length is never folded. We call the excess length 2 beta. It is split into 2 equal pieces, beta, one at each end of the sample next to the clamp. There is one equation that covers all these cases. The testing length equals the stroke divided by 2 plus pi times the folding radius plus 2 beta. Actually, there is a second equation that is used to calculate total length L prime or testing length L from the other. L prime is L plus alpha 1 plus alpha 2. We are ready to mount our first sample, the normal case. The entire length of the sample using the maximum stroke. We will set folding radius to 10 millimeters, stroke to 120 millimeters, and excess length to 0. Our equation tells us testing length equals stroke over 2 plus pi times radius plus 2 beta, and that will be 60 plus 31.4 plus 0 or 91.4 millimeters. Our total sample length will be 122.4 millimeters. Before mounting the sample, we need to set up the jig. The folding radius will be 10 millimeters. The jig settings are marked with diameter. That means we want the jig setting to be 20. Right now the jig is at about 40, so we need to lower the upper clamp. First, loosen the 4 locking screws. Then turn the adjusting screw. Stop when the top of the clamp is at 20 on the scale. Tighten the 4 locking screws. I have found with the smaller radius samples that it is hard to get my fingers inside the sample area, so I remove the plastic portion of the upper clamp. Mount the sample on the lower clamp first. The lower clamp length of 9 millimeters is consistent with just barely having the sample stick out under the far side of the lower clamp. Then curl the sample up and over the upper clamp. Hold it there and replace the plastic portion of the upper clamp. The upper clamp length of 22 millimeters is consistent with having the edge of the sample exactly at the end of the dark portion of the upper clamp. Note that it is important to tighten the upper clamp screws evenly to keep the plastic portion level. If it is not level, it will affect the folding radius. The bottom of the plastic portion should be the same height above the moving slider as double the folding radius. Next, I make sure the DM-LHP is set properly. I set -SP to 0 and +SP to 120. I set the target to 10 cycles and set the speed to 20 RPM. I reset the count, then I touch Start, and then I touch Confirm, and the test begins. I will speed up the video so the 30-second test is completed more rapidly. Now the normal test is complete. We are ready to mount our second sample, the long case. This sample is longer than the case 1 sample, but we will use the same jig setup. We will set testing length to 131.4 millimeters, folding radius to 10 millimeters, and stroke to 120 millimeters. Our equation solved for beta tells us that beta is 1/2 of L minus stroke over 2 minus pi r, and that's 1/2 of 131.4 minus 60 minus 31.4, and that's 20 millimeters. The total sample length is 162.4 millimeters. The jig was already set up for this case. The folding radius was still 10 millimeters. The stroke was still 120 millimeters. I mounted the sample as before. The DMLHP was already set up properly. I only needed to reset the count. Then I touched Start, and then I touched Confirm, and the test began. I have treated this sample differently from the other samples. I have marked 2 lines across the sample. The lines are at the junction of the non-folding portion and the folding portion of the sample at each end. You can see that the sample on the clamp side of the line stays flat at each end. The portion between the lines is being folded and unfolded. You can see the 2 lines. On the left side, the line is always visible, and it is exactly 20 millimeters from the edge of the upper clamp. The line that you see on the bottom right when the moving clamp is extended is exactly 20 millimeters from the edge of the lower clamp. Now the long test is complete. We are ready to mount our third sample, the short case. The sample is the same as the case 1 sample, except we have cut it shorter. We will set testing length to be 62.8 millimeters, folding radius to be 10 millimeters, and excess length to be 0. Our equation solved for stroke tells us stroke is 2 times the testing length minus pi times the radius minus 2 beta, or 2 times 62.8 minus 31.4 minus 0, or 62.8 millimeters. Total length is 93.8 millimeters. If pi r is less than stroke divided by 2, there will be a portion of the sample that is always folded and never straight. And with the long sample, there is always a portion of the sample that is always flat and never folded. Often it is preferred that all portions of the sample go through folding and unfolding. A general conclusion might be that you normally want beta to be 0 and pi times the radius to be greater than 1/2 the stroke. There is a very important point that must be made here. The FU jig is set up to move back and forth from the central point. The central point is when the exits to the 2 clamps are exactly lined up vertically. This was not an issue when the stroke was 120 millimeters, but it is an issue if the stroke is less than 120. The central point of the stroke is at 60. In this case, where we want a stroke of 62.8, the 2 settings must be 60 minus 1/2 of 62.8 and 60 plus 1/2 of 62.8. The 2 settings are minus SP equals 28.6 and plus SP equals 91.4. This change must be made on the DMLHP touch panel. No changes are needed on the jig. Now I need to reset the count. Then I touch Start, and then I touch Confirm. The test begins. I will speed up the video so the 30-second test is completed more rapidly. Now the short test is complete. We are ready to mount our fourth sample, the large folding radius case. This sample is the same width as the previous samples, but it will be cut much longer to have a larger folding radius. We set testing length to be 266 millimeters, stroke to be 120 millimeters, and excess length to be 0. Our equation solved for the folding radius tells us R is equal to the testing length minus the stroke divided by 2 minus 2 beta divided by pi, or 260 minus 60 minus 0 divided by 3.14, and that is 65.6 millimeters. The total sample length will be 297 millimeters. We need to change the folding radius on the jig. First, loosen the 4 locking screws. Then turn the adjusting screw. Stop when the top of the clamp is at double 65.6 or 131.2 on the scale. Tighten the 4 locking screws. With the larger radius sample, I do not need to remove the plastic portion of the upper clamp. I mount the sample on the lower clamp first, then I curl the sample up and under the plastic portion, but over the upper clamp. The DM-LHP settings must be changed. The stroke must be set back to 120 millimeters. Now I need to reset the count. Then I touch Start, then I touch Confirm, and the test begins. I will speed up the video so the 30-second test is completed more rapidly. Now the large radius test is complete. In this video, we have looked at the Yuasa FU sliding folding test machine. We have reviewed the current version as well as previous versions. Differences in the versions are the possible sample dimensions, width, length, clamp length, and folding radius, the design of the floating joint, and whether or not a joint bracket is used. Plus, the current version has an option to have 1 lane for samples or 4 separate lanes. We installed an earlier version on the DM-LHP motor drive unit, and we looked at differences in the installation with different versions. We looked at how the stroke must be centered around the midpoint of the maximum travel of the stroke when using less than the maximum stroke. With the maximum stroke of 120 millimeters, the centering will be at 60 millimeters. The stroke cannot be set at one end or the other end of the travel. It must be centered. By the way, the sample in this portion of the video is the long radius sample, but it is set for a folding radius of 50 millimeters. This is case 3, the long sample, and the excess length is 24.5 millimeters at each end. We set up 4 different samples using different setup conditions for each of the 4 cases, and we looked at how to mount the samples. We looked at 4 different sample geometry cases. We call them normal, long, short, and large radius. The normal case uses the maximum stroke of the DM-LHP motor drive, 120 millimeters. The sample is cut to have every portion of the sample go through both folding and straightening, and no portion of the sample is never folded. The long case is very similar to the normal case, except we cut the sample longer, which results in the 2 ends of the sample never being folded. Often a sample will be mounted this way to keep any folding away from the clamps, just to make sure the clamping is not affecting the folding endurance of the sample. The short case is different because the sample is shorter and the stroke is set for less than the maximum stroke. If the sample is cut so short that pi times the folding radius is less than 1/2 of the stroke, there will be a portion of the sample that is always folded and never straight. The large radius case will have portions of the sample always folded, and typically a significant portion of the sample. This concludes the Yuasa FU sliding folding test machine setup video.